amazing that we have this crowd and basically punctual. It's funny that we expected that we would start around 6:15, 6:30, so because it's common that people keep coming in. We expect also some others to come in, and that's okay. But thank you again for coming. It's a pleasure to have you all here. My name is Basil Kamel, basically a faculty member at the American University in Cairo, originally from Cairo University. I see a lot of familiar faces and a lot of new faces that I've never seen before, but it's great to have you all. Today we have a lecture that will be given by Professor Brook Muller. It's great to have him here. It is part of a group of lectures and a group of series that AUC is trying to host as hopefully an activity that will spill out so that we gather a lot of the young, bright minds, enthusiastic architects, and to start to think a little bit out of the box, think a little bit into interdisciplinary studies, to try to gather more information, more data about how we can proceed with enlightenments of knowledge and enlightenments of outcomes of our work. I will let Dr. Nabil El-Hadi introduce the whole event tonight, talk a little bit about the process of what we're doing and why we brought Professor Brook here, and then we will start the lecture briefly, and then hopefully we will have some time for discussion and for interaction with the lecture and with ideas in it. Thank you.
Thank you, Basil. I will not really talk very much. We are organizing Cairo University in collaboration with the American University in Cairo and Megawa, this initiative which is called Urban Innovation. We organized a competition, architecture competition, late the last winter, and then we had 5 finalists. And at this competition, we address 3 main issues. One of them is sustainable mobility, renewable energies, and urban agriculture. And we address these issues within the context of public housing in Egypt. So it's in some sense, actually, it is an initiative targeting the real improvement, sustainable improvement of public housing in Egypt. And we choose this, the first cycle, we choose a site located in 6th October City in low income housing, built by the government. So it is an initiative that hopefully will keep taking place each year, maybe in different locations. Hopefully next year will be located in the Upper Egypt, most probably in Kenya. So we are deeply interested in the optimizing and having a meaningful intervention in public housing. We do have enormous public housing all over Egypt, and I think it's really provides a significant opportunity for improving the lives of people living there and using the underutilized resources being available there. I think this is a real challenge in the new communities and new cities in Egypt. So our workshop is, and the competition, the whole initiative actually aims at not only producing ideas, but taking these ideas into the realm of being really implemented. So the workshop aiming at supporting the finalists into developing their ideas, taking it a little bit further in collaboration with the community and with the other stakeholders, local authorities, so that hopefully we'll get some of these ideas, maybe one, maybe more, hopefully implemented. So we have as well financing collaborators, developers, local actually developers. So it's an initiative aiming at creating a condition for sustainable development that is not only aimed at this particular site, but it hopefully will generate a generic intervention, hopefully that will be taking place otherwise. This is what we do, and in doing that, actually, we always use help actually from outside our whatever circle. And we don't have really great friends, and great friends actually usually recommend you other great friends as well. So it's we really privileged to have Brook Muller here with us, helping the participants, mostly freshly graduated. Some of them are still actually students, senior students, helping them developing their ideas, discussing their ideas, and I think up to now we are now like 2 days in the workshop. We're having 2 sessions of serious discussions and intense. And I think thanks to Brook Muller, actually, he's actually leading it, and he's with Amr Abdel-Awi and May and Ambassador, of course, giving us really great support. Brook Muller is the interim dean of the School of Architecture and Allied Arts at the University of Oregon. He's also associated professor of architecture, with mainly sustainability sort of main interests and main whatever scope of work. And we really like having you here with us, and we're really delighted to have you here today giving us your lecture. Thank you very much.
The feeling is mutual. Can I put this down? Can you hear me? Okay, perfect. I have a lot of thank yous to make. First of all, what a great turnout. I've actually never lectured in a nicer room in my life, so that's good. The Ford Foundation, the Institute for International Education helped sponsor this trip. Basil Kamel and Amra Abdelkawi from the American University in Cairo. I really enjoyed interacting, getting to know you the last day or two, and working with you. Mai Al-Abrashi with Mugara, she's incredible, great part of the team. I met Heba Khalil 3 days ago, on the water, sailing down the Nile. It was fantastic. And of course, really my host for this trip is Nabil Al-Hadi. I feel like we were friends within 5 minutes, and I've really enjoyed getting to know the city of Cairo and the architecture of Cairo through Nabil. And I would also just like to say how impressed I am with the competition and the workshop, and how fun it's been to work with the teams on the Urban Innovations project. And they do have the potential to do something really impactful and meaningful, and it's really an honor to be a part of that. Basil said, I like the use of the word furnishing in your lecture, and there's a kind of story behind it. I borrowed that term. In 2001, I participated in the first Glenn Murcutt Master Architecture class in Australia. So the Pritzker Prize winning architect had a couple other architects working with him, teaching this really incredible 2-week class, which they still hold every year, by the way. And we were in this rural area of New South Wales, the rolling hills, and we were asked to design a gallery in this bowl-shaped meadow. And we were out there one morning with Richard Laplastriere, who's an architect, a colleague of Glenn Murcutt's, and his comment was, the role of the architect is to furnish with particular purpose this larger room that we are in. And I've never forgotten that. I think that's a beautiful way of describing architecture, even in an urban environment. If you thought of a work of architecture not as an envelope, but the positioning of sets of furnishings within the urban landscape, it could start to generate some different ways of thinking about what architecture can be. So I'm going to share some projects, some real, some theoretical, and they may not translate perfectly to this climate or context. And so the goal would be to be thinking more in terms of an approach to architecture and architectural ecologies, which I hope that term will be really clear by the time that I'm through. And I'm going to start out with a couple of early projects in my practice career that have really set a foundation for my teaching. And also my teaching is a collaborative venture. I work with ecologists and economists largely in thinking about architecture at the intersection of ecology and economies. And I hope that should be clear as we go along. So I was very fortunate when I graduated from architecture school. I went to Stuttgart. I knocked on the door of Danish and Partner. I said my German is sehr schlecht, but I would really like to work in this office. And they hired me And they put me to work on this competition, the Dutch Institute for Forestry and Nature Research. And we ended up winning the competition. I thought I would be there for 6 months. I ended up living there for 4 years working on this project. And so basically we're out in this cornfield in the eastern part of the Netherlands, and they wanted to take these different departments, wildlife, biology, landscape ecology, aquatic ecology, and put them all under one roof, this Federal Research Institute. And there were offices and labs were the two main components programmatically. And so the first idea was to actually separate the laboratories from the offices, because the laboratories are going to require strict mechanical ventilation, whereas we had opportunities with the offices to rely primarily on passive or natural ventilation. So the first idea is to separate out the parts if they have fundamentally different energy requirements, and you can actually start to make some inroads in that sense. The other idea on this cornfield, so these people do forestry and nature research, and it's a cornfield. So we introduced these gardens, these postage stamp shaped gardens, this array of gardens, and each one represented a different biotope of the Netherlands. So a wetland garden, a meadow garden, a forest garden, and then we grew the building between the gardens. So you usually think of the garden as the thing that changes and is dynamic, and the building is something that's fixed. And we wanted to reverse that and have the garden be the armature within which the building grew. So should this research institute be successful and have to hire a lot more people and get a lot of grants and they need to add on, it's a weak form building by design, and it's very evident where you would add on to it. At the intersection of the office wings and the garden, where they overlap, we introduced these greenhouses. So you can see the greenhouses here. Single glazed, off-the-shelf technology, very inexpensive, available throughout the country. And we thought of those as energy buffers for the building. So in the summer, during the day, you deploy these shade cloths and try to keep the atrium spaces cool. And at night, you would open it up and bring the cool night air through and try to cool it off. In the winter, you'd do the opposite. You'd have the shade cloth deployed at night to block the heat and open it up during the day to capture the sun. And so this is what it looks like. And so one of the other ideas that I'd really like to communicate with this lecture is there's an idea about sociability and how people interact, and there's an idea about energy performance, and those things are not separated, they're actually one and the same. So the sociability diagram and the ecology diagram are one and the same. This is a very, by Dutch standards, a very inexpensive project. We've largely reduced, there's no air conditioning for the offices, really reduced reliance on mechanical equipment. We capture all of the storm water, divert it to cisterns, use that water to water the plants. The evapotranspiration of the plants has a cooling effect. Really trying to think of a set of very simple systems that interact to create a low energy building, which is also a really delightful place to work. And so you can see how dated this is. See the computer right there? That's you can tell that's this is a 20-year-old building. Okay, so the idea that the ecology diagram and the social diagram intersect. I went, after my experience in Germany, to Southern California to work with Blackbird Architects. And we were hired to do the Air Pollution Control District headquarters for Santa Barbara County. And it's a very inexpensive building. It's basically 2 boxes, an L shape. And what we did is we took wooden telephone poles, which are really inexpensive, and we marched them across the south facade and then strung canvas to it. And that's a shade element. And then we planted wisteria vines. So this is during construction. And those wisteria vines grow up. The canvas deteriorates over time. And then the wisteria starts to take over. And so for the Air Pollution Control District of Santa Barbara County, their billboard is this living facade. And that when you open your window, wisteria has a really nice scent. You get the scent of the wisteria coming into your office. So in the United States, interior space is $300 a square foot, and landscape is $15 a square foot. So my recommendation would be to try to think about how landscape elements could be incorporated as part of the very basic bones of the architecture. Okay, I'm going to give you a little bit of an introduction to, do we want to?
Yeah, we'll
Okay.
add some chairs.
Okay.
If you don't mind.
No, I don't mind.
We'll
I'm
try to add
amazed
some
and-
chairs.
So that
we can have as much as possible.
Not at all. I hope I can live up to the crowd. I'm so impressed. I should have brought my book, copies of my book.
You should have brought it.
Sold it, sold signed copies. Should I? Just one. So now those are the kind of foundational projects in my architectural background. I want to talk a little bit about where I come from because it's also relevant to the work that I do, clearly. So I live in Oregon on the west coast of the United States. Here's California, Washington, and British Columbia, Canada. So I live in Oregon, but people call it Salmon Nation, and salmon is this really significant species. It was significant to the Native Americans who lived here centuries ago. And so it's sort of a social symbol, and it's also what's called an indicator species. So if you have healthy salmon populations, that means you have intact forest habitat and other habitat, because it's sort of an indicator of the larger health of the watershed. So it's very significant. So basically there's this thin sliver of temperate rainforest, and then if you just go east of that, it gets much drier very, very quickly. The Native Americans who lived here are thought to be one of the only cultures in the history of the world that were not non-agriculturalists. They did not practice agriculture, but they stayed in one fixed location. They weren't nomadic, they didn't practice agriculture. There was so much fish that they relied on fish. So they actually called the sea their home, and they would be out in their home during the day, and at night they would leave their home to go to sleep, and then they would go back out to their home the next day. It's kind of a beautiful thing. So here's the Pacific Northwest. Here's that temperate sliver that I described. Here's Portland, Oregon, Seattle, Washington, Vancouver, British Columbia. I live in Little Eugene right here. The Coast Range, the Cascades, and then the high desert. So I'm going to show some images. And so this is the Willamette River watershed right here. Just to point this out. So here's Eugene, Oregon. The river flows north to Portland, Oregon, to the Columbia River, and out to the Pacific. So you have the Coast Range, which gets incredible amounts of rain, the Cascade Range, incredible amounts of rain, and then east, almost no rain at all. So this is just about an hour east of where I live. Some of these trees are 70 meters tall. It's really just astonishing. But if you drive another hour, it looks like that. So it's very stark. It's like driving up out of the Nile Valley in a way. The water availability is really incredible. By the way, there was a University of Oregon anthropologist who found the oldest pairs of shoes that has ever been found in a cave here. So that this used to be a lake, which is I think they're about 12,000 or 14,000 years old, somewhere to that effect. We have Nike in Oregon, so I think there's a connection. We've been doing this for a while. And so basically in the American West, we have, over a longer climatic history, we have ice ages and then interglacial periods where it's much warmer. And we're thought to be in an interglacial right now called the Holocene. And so it's much warmer over the last 10,000 years than it was 13,000 years ago. And it's getting quite a bit warmer. So this is where that cave, that Fort Rock was, where the shoes were. And this is Nevada and Utah. And these are historic lakes. And then the remnants of this lake is just this lake, Lake Tahoe, and Pyramid Lake. So over the last several thousand years, it's getting much warmer and much drier. And of course, now we have climate change. So I'm not sure if it's the just natural climate cycle or climate change, likely some combination. But the last couple summers, we have had enormous problems with drought. California is suffering through 4 years of very severe drought. And so this is the reservoir for the city of Sacramento, California, the capital of California. That's what it looked like a couple months ago. It's rapidly disappearing. All the water comes from, the drinking water comes from snow that falls on the ridges. And then it slowly melts, and we capture that water in reservoirs. That's our drinking water. It hasn't snowed in a couple years, so the water's disappearing. When it snows, the soil is always wet, and it prevents forest fires. If there's no snow, it's very dry, and we have these astonishing forest fires. So when I left Oregon to come here, I flew from Eugene heading east, and it was just for the first 2.5 hours, it was just fires everywhere. I called my wife this morning. It was last night in Eugene, and she said the airport closed. There's no visibility. We have a really big problem. And then our projections moving forward are even more severe problems. There are different scenarios for how climate change might play out. Here's the Pacific Northwest. So it looks pretty good, relatively speaking, under all scenarios. If you're in Phoenix, Arizona, or Las Vegas, or Los Angeles, it looks bad under all scenarios. California has 40 million people, Oregon has 4 million, but we're currently witnessing an exodus of people from the southwest to the northwest, and so we're bracing ourselves for significant growth over the next couple of decades. So here we have, it depends on how you measure it, but some say the largest infrastructure project in the history of humanity, the California Water Project. And we're bringing water from mountains with snow to Los Angeles, but there's no more snow. So this vast infrastructure is quite vulnerable, actually. And it turns out that 20% of the electricity consumed in California is used to move water. So it's really this combined problem. So here's Las Vegas, and I've mentioned this to a couple people. This is a new casino project, and it's LEED Platinum. Do you all know what LEED is? The environment. So this is the highest environmental performance rating that a building in the United States can have. And it's inoperable windows, fixed windows. The electricity comes from the Hoover Dam. The water is so low that pretty soon they're going to have to turn off the turbines. They're not going to be able to run electricity. We're going to have brownouts. If you're in a building in Las Vegas with inoperable windows and it's 115 degrees Fahrenheit and there's no electricity, they estimate that you have between 15 and 20 minutes to get out of the building before you asphyxiate and die. Okay, so that's our top environmental rating in the United States. This is a problem. So I'm very proud to be at a school, the University of Oregon, that really looks first and foremost at passive design principles. We're the #1 ranked program in the US for that. And it's based on people like G.Z. Brown, who've been looking at natural heating, cooling, lighting, and ventilating of buildings for a very long time. So the first thing you do is be intelligent about the orientation of the design, the organization of design, aware of the climate, and only secondarily do you then add mechanical systems. You save money, you save energy, and you can make better buildings as a result. It's more interesting architecture. We also look at these issues at a landscape scale, so our landscape architecture department. Dave Holst looking at the Willamette River Basin, developing these really interesting models that look at land use change, climate change, and population growth, and different assumptions about each of those variables and how the future of this region is going to play out. Really, really interesting stuff. And then also affiliated with this entity in Portland called Eco Districts. So sustainability is not just energy, and it's not just water, and it's not just mobility, and it's not just habitat and all these other factors, but it's really thinking synergistically about how these things interact with one another. So we can rely on less energy, less material, less effort to make buildings that are more intelligent. And frankly, I had a tour of some medieval Islamic architecture in the city, and that's just some of the most intelligent architecture you will ever see from a climate adaptation point of view. It's like we have to return to our history to look for ways of making architecture in the future. But I really like how they're saying, the building scale may not be the scale to address this most optimally. My building site is high and dry, and it's great for collecting the sun, and yours is low and wet and great for collecting water. So why do I have to do all of the work myself? How might we partner to achieve greater efficiencies? So this district or neighborhood scale may prove to be the most effective scale to be thinking about this stuff. But that's going to require new finance models. And so in addition to the design, how are we going to fund this thing? So my site's high and dry and yours is low and wet. What incentives do we have to pool our resources? How does the money flow? And so people are actually working on finance models that incentivize these kinds of partnerships, which I think is really, really critically important. My own particular work, actually working with an ecologist, we start to ask, what roles can individual site-scale architectural projects play in supporting broader ecological function? And it's a pretty interesting thing if you start asking yourself, when you work on your projects this coming semester, if you're a student in a design studio, what's the role of my project in the watershed? What's the role of my project relative to these larger ecologies? And so at the massive scale, the city scale, Bureau Happold's new city in China, we can start to think about green and blue as part of the infrastructure of the project. So wetland complexes for stormwater collection to prevent flooding, to provide habitat, and green space for the lungs of the city and for wildlife connectivity and all these things. That's all great for a new city. I tend to work in existing environments. The city's already there. I have this little site, and I'm trying to think, how can the aggregate of smaller scale moves start to build something more functional from an urban ecological point of view? So this is a suburban project, a retail project, but it's actually the site plan is such that you're protecting and supporting the hydrological function of adjacent wetlands. So the building is actually collecting, filtering, cleansing water, the green roofs, before it's directed to these wetlands. And so again, there's some interesting synergies that we can start to create. I had a student working on a high density in Oregon is a 3-story building, okay? Just to put things in a little context here, okay? we start to get nervous when we get up to 4 stories. It's like, wow, big city stuff. So just so you know, but he was looking at a building in downtown Eugene and looking at this fragmented butterfly population in the southwest hills and the northeast hills, and he started to realize if I plant Kincaid's lupin, the larval host plant for this butterfly, on my roof, I could have a stepping stone for that population to intermingle, ensure a more diverse gene pool, and ensure the long-term survival probabilities of this species. So using elements of buildings as part of a strategy for ecological regeneration. And if you think that's crazy, many of you have probably seen the California Academy of Sciences project by the Renzo Piano Building Workshop. And I got to meet this guy, Paul Kephart from Rana Creek Living Architecture. He does the largest green roof installations in the world. And so here's Renzo Piano with this beautiful, evocative sketch of this roofscape that's mimicking the Golden Gate Hills of San Francisco in the background. Paul Kephart, who installs green roofs, he's looking at this undulating roof and he's like, this is amazing because I only do flat roofs. And if you have an undulating roof, you have a shady spot and a wet spot and a dry spot and a sunny spot. And I can create a much more diverse set of ecologies on this rooftop. So he calls his work acts of eco-sabotage because he uses native wildflowers and grasses he plants on these roofs. So he's thinking about roofs as nurseries for endangered species, which is pretty incredible. Sometimes the architects don't know it. Sometimes they do. So a green roof, so where I live, we get a lot of rain in certain periods of the year. And with all of these hard urban surfaces that are polluted, that rain gets directed really quickly to the waterways, and we have flooding, and also the pollutants kill fish and other species. So the idea is to have green roofs reduce the rate of stormwater flow to water bodies, to moderate the temperature inside the space itself, to reduce the urban heat island effect. But Paul Kephart's saying we could also start to think of these as part of a connective system for macroinvertebrates, bugs that are flying around, that birds then will be attracted to. So birds making their way up and down the Pacific Flyway. I love the idea that one building is part of a hemispheric migration. It's a pretty beautiful thing. And there are people who go up on this roof to do bird counts, and it's really working the way that it was intended. Of course, I don't know how many millions of dollars per square foot this project is, so it's not like this is going to solve our ecological degradation issues. And then this guy has a nursery, and he's devised these really innovative trays to transport things. They're made out of coconut fiber, and you can just lift them into place. Over time, the coconut fiber deteriorates and provides nutrients for the plant. So pretty thoughtful approach. But it doesn't have to be habitat, and it doesn't have to be expensive. So I thought I would just show this one last project before moving into the second half of this talk. So this is a fairly new, very modest project called the Burnside Rocket in Portland, Oregon. It's sort of this light industrial part of the east side of Portland. And there's the restaurant on the top floor, and then there's they wanted to do an integrated green roof, but they didn't have the money. So they bought a bunch of plastic children's pools, kiddie pools. They drilled holes in the bottom, they put them up on concrete blocks, and then they're growing food. So if you order a salad in the restaurant, it's coming from above your head, up in the roof. And what they're finding is that the microclimate of the roof extends the growing season in this cold climate by 2 to 3 weeks. Okay. So one of my favorite authors, this guy David James Duncan, wrote an autobiography called My Story as Told by Water. And because my name is Brook, I'm going to tell my story of architecture as told by water. If energy was the first generation of sustainable architecture and climate change and carbon footprint the second, there's no question. And everywhere I go, everywhere, people have water. They're confronting major, major water issues. So let's think about that. This is a typical house where I live. It's called a craftsman style house, a bungalow. And all of our buildings that are small are made out of wood, like almost every part of the building. And so what I learned in school is because it's a wooden building and wood rots, you need to have eaves that extend well past the roof. And that might be a nice bracket detail, but that's going to rot. That's called a rot vector right there, and you want to avoid that. And then we learned a lot about flashing details. And I love flashing details. I get really excited about flashing details. So this is a wooden house and a wooden deck, and this is the ledger that you bolt through to this ledger, and then you have to flash this ledger. What's interesting is the detail calls for copper or galvanized steel flashing. So if you have enough money, you'll use copper because it lasts forever. But I had no idea until I started working with an ecologist that 12 parts per billion of copper in the urban stream can actually be incredibly damaging to salmon and other species. It affects their ability to smell, which is their primary means of defense. So if there's a predator swimming around and chomps a salmon, the salmon sends out pheromones into the water, and then the other salmon all drop and go still. And if they have copper, they can't in their noses, they can't smell, and they just keep swimming and they get eaten. I had no idea. Okay, so the next exposure I mentioned at the very beginning, this Glenn Murcutt masterclass, and this was where we got to stay for this class, a Project Murcutt design in New South Wales, and the gallery they asked us to design was immediately adjacent. It's a really brilliant project. There's these sleeping quarters. It's the sleeping quarters in this long bar, and then the meeting space right here. And these two elements meet in a valley. So this is off-grid, and there's no municipal water supply. So all the water collects in the valley, is diverted to a cistern for use in the bathrooms and the kitchens. So you can see this elaborated valley roof, the valley, and a typical Murcutt celebrate the downspout thing. Look at the environment in which this project is situated. Valley, valley, water collection. Valley, valley, water collection. The building is a poetic analog to the environment in which it finds itself. I think that's a really beautiful idea. And then, actually, this is pretty neat. So here's a great passive. So these fins are shade devices for the east and west light, the low sun's light. But they also house pocket doors so you can convert a two-room space into a four-room space. I think that's very clever. And then you have this fixed light here. So when you lift your head up in the morning, the first thing you see is the river. And if it's raining, you can see the raindrops. And if it's sunny, you can see the reflection. And so the building is the registration of the environment. It's been choreographed to enable you to understand the larger condition. Okay, this is maybe a little bit of an aside, but the class ends, and I always wanted to see the outback, so I rented a RV, and I was driving on the other side of the road, and I'd never done that before, so I pull out of the parking lot, and I get in an accident in like 13 seconds after renting a car, which isn't great. But I drive out into the outback, and it's completely flat, and off in the distance is Mutawinji National Park, just these low hills. And because it's flat, you only need to get up 30 meters, and you can see forever. It's really neat. But this is hard bedrock, hard geology, whereas everything else is granular. And so where you have a little bit of verticality, you have shade. And where you have hard geology, you can capture water. And where you have shade and water, you have plants. And where you have plants, you have animals. And where you have animals, you have people. This thing was scratching on my tent one morning. It's like, what is that? It was a kangaroo. I have a colleague in landscape architecture named Bart Johnson, and he said cities are rock outcrops. From the standpoint of pretty much every species other than a human being and pigeons, cities are rock outcrops. So we could start to think about diversifying urban environments so they are supportive of other things. But actually, a rock outcrop creates shade. It's a place to collect water. So if we could appropriate some of our urban environment to that instead of automobiles, we could really start to do some amazing things. Okay, so I've talked a little bit about salmon. There's one other piece that I'd like to mention, and that will make sense as we get into the last couple projects that I'd like to share this evening. So where I lived 500 years ago, it was an oak woodland, and when it rained in the winter, the water would hit the leaves and go down the bark and hit all this leaf litter and very slowly make its way to the river. And in that process, the water would be cooled and cleansed and oxygenated, oxygen-rich water. And the river wasn't channelized. It was actually much wider than it is today. And when it rained a lot, it would overflow its banks and create these side channels. Today, with parking lots and buildings, the water hits those surfaces, picks up the pollutants, motor oil, heavy metals, very quickly makes its way to the urban stream. It's polluted and warm, and we channelize the river. So we put it into this pipe, and now it's going really, really fast, and that turns out to be really devastating for salmon species, which is like the cultural icon of the region in which I live. The coho salmon, they are born in the upper tributaries, make their way down to the ocean, get big, the females get pregnant, and they go back upstream to their historic tributaries. The trigger for them to go upstream is the first fall rain. So it doesn't rain all summer, and then we start to get heavy rains in the fall, and that's the trigger. So imagine the first rains pick up all of that pollution and dump it into the river really quickly, and we have 70% die-off of salmon as a result of that. So there are people, landscape architects who, like Herbert Dreisaitl, he wrote this amazing book called Waterscapes that I would really encourage, if you're interested in this, be a great book to look at. This is a new park in Portland, Oregon, and so we're starting to create these stormwater management parks in effect, and really trying to look at the aesthetics of what that might be all about. I've had students explore possibilities for it rains, it's kind of cold, it's almost freezing, and it rains all winter and it's sunny all summer. So maybe we don't want to spend a lot of time outdoors in the winter. Maybe this civic space is a stormwater reservoir in the wintertime, and it's a flower market and farmer's market in the summertime. So we could start to have multiple uses associated with one urban space. Or a project by Sam Russick. So this is a residential project of these wings along a river. And so here's a wing of houses, high density Oregon, okay? What I'm really interested in is, can some of this actually play out in a much denser urban environment? It's one of the reasons I'm here. I actually am convinced that it can, what we need to work on it. But here's some residential wings, and here's a stairway to get you up to the upper level. So where the people collect is actually where the rainwater collects in these cisterns, and then it's used in the building, and then the excess water filters through this permeable walkway. So here's the two wings. Where the people collect is where the water collects, and instead of the water sheet flowing, it starts to have this undulating journey to the river. So the social diagram and the ecological diagram coincide. Similar idea with this particular project. Paul Kephart, the guy who did the green roof for California Academy of Sciences, working on the Transbay terminal in downtown San Francisco. And so this project is where the BART, the subway, and the bus lines and all these different transportation systems come together. It gets really humid down below, and the air gets stale really quickly underneath the ground where the subway is. So you continually have to bring fresh air in and reject that moist, stale air. And so most people would think, my job is done, I've rejected the moist air. He says, what can you do with that moisture? And so what he's going to do is create an estuarine ecosystem on a roof in downtown San Francisco that's going to provide habitat for 27 endangered plants and 8 endangered animal species. I don't think this is going to solve the fact that we're living in the 6th mass extinction in the history of humanity, or the history of the world, excuse me, but I think as a symbol of what is possible in this dense urban context, I think it's pretty interesting. So we start to think about the kind of the physics, the moisture, the behavior of buildings in relationship to the larger atmosphere, and really starting to think about architecture as these systems that are thoughtfully and efficiently interacting with one another. I think it's an interesting direction for architecture. So HiFi Design Laboratory in Oakland, California, they collect all the moisture, the condensate from the mechanical systems on the roof. They use that water to grow green roofs on the roof. The green roof has a cooling effect on the spaces underneath, so you can minimize your reliance on the mechanical system, and you really start to think about this as this integrated system. And perhaps my favorite example would be the new SF MoMA edition by Snohetta, San Francisco Modern Museum of Art. And Snohetta, they wanted this living wall in the courtyard, but they hadn't really figured out how to get water to the living wall. And HiFi Design Laboratory calculated that on a typical day, there is 1,200 gallons of condensate buildup in the interior spaces of the building. That is the sweat of human beings. And we're going to direct that water to the facades, and we're going to direct it to the living wall, and that's where your water comes from. So you might want to think about working with a biologist, because it's really, and I'm more and more convinced. So we start with space and then add systems. And what would happen if it started an architectural project with the water systems and then built space around it? It might be worth speculating about that possibility. So that leads me to the last project that I want to talk about. A machine is a watershed for living in, and I hope you get the architectural humor. Do we get it? It's a take on perhaps the most famous proclamation of architecture in the 20th century. Le Corbusier, Towards a New Architecture, 1923. The house is a machine for living in. Probably, again, the most influential sentence in architecture in the 20th century. All architectural theory since then is basically commentary on that sentence. I'm thoroughly convinced of it. Okay? And so, okay, is the organism the metaphor for the 21st century? And we could have this conversation. So the idea is to collect the water, make use of it. And I know your hydrological system here is fundamentally different, but we get a lot of rainfall. In an era of climate change, it's increasingly fewer and more severe events. So we want to capture that water. We want to put it to work as thermal mass to keep the building cool, as seismic dampening, as fire suppression, for uses for kitchens and other things, bathrooms as well. We're going to clean the water in the process, and then we're going to time the release of the water to the nearby adjacent water bodies to flush the system with clean water when the system needs it the most. So there are going to be fish making their way upstream, and there's going to be a detector in the stream, and it's going to tell the building the fish are coming, and the building's going to tell all the other buildings the fish are coming, and then we're going to send that water, we're going to send that clean water to the stream to enable, to dilute the poisons that they're having to deal with. So we thought we would take as a studio project a parking garage. In the early history of the parking garage in the United States, it was a full-service operation. So you'd pay to park, but you'd also get a car wash, tune-up, and oil change. And so we're going to reintroduce that full-service deal. We're going to collect water from all the neighboring buildings and the adjacent bridge. We're going to divert it out of the hydrological system. We're going to bring in these pollutants called cars. We're going to give them a bath. We're going to heavily step cleanse that water, and then we're going to time the release of that water to the wetlands that we're actually going to create as part of this project. So we've had increasingly dry springs. The macroinvertebrates, dragonflies and other flies are all, they can't live because the water levels are too low. Their early life histories are in the water. And so we're losing this whole food chain which birds depend upon, which fish depend upon. It's kind of an instantly catastrophic ecological situation. So what we're going to do is we're going to use the relative hardness and predictability of the urban environment to support these processes in a time of climate change. So here's our site in Portland, Oregon. This is called the South Waterfront District. It's about to develop. We're going to have 30-story buildings. I know it's kind of hard to believe. And the reason it hadn't been developed was that they built ships here during the Second World War, and they dismantled ships after the war. And as a result, there's cobalt and PCBs and all this awful stuff in the soil. And they realized the safest thing to do would be to cap the soil as opposed to removing it and digging into that stuff. So they put this geotextile mat, the thickness of a LP record, down over the entire site, put earth on top of it. Our ecologist consultant, Mark Wilson, said, "That's perfect. That's wetland subbase. You've created it." This guy, he follows construction equipment around construction sites, and he is watching these trucks compact the soil, and he does percolation tests of the soil. He's like, "You've created wetlands. Just add water. You've got them." So the idea that construction processes could be regenerative biological and ecological processes is pretty interesting. So here we're going to be, our parking garage is going to be back here. We're going to collect the water, pull it out of the cycle, clean the cars, send it to this system of kind of quasi-riparian pre-treatment gardens, and then ultimately to, this is the longitudinal section, ultimately to these wetlands, and then that cleansed overflow will make its way into the Willamette River. This project uses a mechanical lift. So you get out of the car gets a bath, it gets lifted to a drying rack. You take that contaminated water and you divert it to the facades to grow algae, and by growing algae you clean the water. You take the algae and you produce biofuels with it, and then you take the cleansed water and you send it to wetlands and then to the river itself. So we're going to make a motorcycle fit within the hydrological cycle. Just a couple of more projects. They were going to use mycofiltration. They're going to use mushrooms to clean water. So we're going to be in the forest of cars, underneath the canopy of cars. And we're going to spray the cars with the water, and we're going to clean the water through mushrooms. I like this scheme, very simple, because basically they're saying Portland has a goal of reducing automobile traffic by 50% in the next 35 years. So we're not going to need parking garages. So we're going to convert these to greenhouses for urban food production, and they were thinking about that as part of the design. And then just a couple more. This is an idea of almost these parasitic, these prosthetic devices, these filtering elements. They're where stairs are, but these stepped, living, cleansing elements for the water that you could attach to parking garages, to office buildings, this kit of parts that you could attach to buildings throughout the urban environment. I have to give my student team props. This group of 3 third-year undergraduate students submitted their project to the Cooper Union in New York for the Royal Society of Arts Awards last year, and they ended up sweeping the awards, the architecture awards, which makes me very proud, because if you're in New York, Oregon is off the edge of the civilized universe. It's just like, it doesn't even exist. So to go in and to take home the bling, I thought that was pretty good. It made me very proud. They're like, you can use a parking garage to do what? Okay, one last point I'd like to talk about, or one last thought about architecture before we finish. David Leatherbeer is a very well-known architectural theorist at the University of Pennsylvania, and he wrote this wonderful book called Uncommon Ground. And in this book, he talks about 3 architectural horizons. So there's the equipmental horizon. This is the seats that you're in, the sort of furnishings that make possible this lecture this evening. The practical horizon is the roof over our head, so it doesn't rain on us, or the walls to our sides. And then lastly, the environmental horizon, which is the environment beyond the practical and the equipmental and the practical. And as I start thinking about these kinds of projects, one thing that I get really excited about is that we're going to basically, it's not, there we go. We're going to reconstitute architectural horizons. So this Meccano Architects competition entry for this library in China is basically, the architecture is an environmental horizon and an equipmental horizon that are collapsed and put together. That's basically what it is. And then maybe the practical horizon is the watershed within which that building is situated. This is a project that these students in a Rome studio did, a 2-week charrette, where these are sand filters in concrete, and basically you walk into this space. It's cleansed water. The water supply of Rome is probably the cleanest water in the world, but something happens between the water that comes in and the water that goes out, and the Tiber River is horribly polluted. So the idea is, you walk down, it's a hot summer day in Rome, you're in this cool environment, you go up through this slot stair, you make your way to the roof, to the ubiquitous roof gardens of Rome. You look out into the distance and you see the aqueduct where the water came from. You make your way down through these bio trays that are filtering all the gray water from the neighboring apartments, and you make your way throughout the city. So this sort of kit of parts, again, prosthetic device, where the practical horizon is this larger space. We're going to furnish this larger room, and the architecture itself becomes a fusion of the equipmental and the environmental. And that is also what I think that project begins to communicate, and where I'd like to investigate the possibilities further. So thank you. Thanks.
Thank you, David. I think this is very interesting. A lot of issues raised. I would like actually to just jump directly and open the floor for questions. And then through the questions, there could be some commentaries and some issues that are being raised. So give us your thoughts. Give us your ideas. Ask.
لو حد عايز يسأل بالعربي.
Oh, you can, and then we translate. And we can translate.
Yes.
Asking about
علي صوتك بقى علشان الناس تسمع.
the feasibility of planting roof. For example, in a country like Egypt, we spend a lot of money to insulate this roof.
Yeah.
And I thought actually they will insulate it perfectly, not to.
Oh yeah. What do you deal with? How do you deal with that? That's an excellent question. There's a tremendous amount of enthusiasm to do these integrated green roofs right now. There's also what are more disintegrated green roofs, where you lift the container off the ground, like the kiddie pool. You can do it really inexpensively or more expensively. So I think there's got to be a way that you can follow the water and make sure it's not causing a water damage problem. I actually start to get a little bit nervous about the integrated green roof with membrane and all this stuff. What happens when it starts to fail? Are you going to be able to detect where that is? Sometimes a disintegrated approach is perhaps more promising than an integrated approach.
Okay, yes?
What is the best way to measure the benefits of building that has ecological system and compare it to like a building that has a leak platinum? How to measure benefits like moving the sun with like green hosting butterflies on the hill? How to quantify?
Yeah, that's a really good question. There's a whole sort of ecosystem services finance models would probably be the most. That's what my ecologist colleague Josh Serra does. He's at Cornell. So he looks at ecosystem services, and you can measure the value of constructed wetlands that are part of a project development, we get all of these intense rains, and we've channelized the river, and we start to have flooding problems, and we have 100-year floods every 5 years now. And so we talk to insurance agents. I mean, we can start to quantify it in those terms. I know I'm naive, but do you want to put a dollar sign on a endangered butterfly? I don't know. But so there is the sort of the quantification, which has to do with the functional integrity that you're reintroducing to prevent things like flooding. Is there any value to clean water? Is there any value to cleaner air? And there are these emerging, again, ecosystems models that start to put dollars on those things. But I think there's a point at which, so if I do a green roof and I've reduced the urban heat island effect and I can quantify that, and I can reduce the cooling loads of the building and I can quantify that, and if it just so happens to be butterfly habitat, it's not going to get value engineered. They're doing wetlands on factories in Germany, and they cost more because the structural load is greater, but they found out that the cooling loads have been reduced so much that the payback is in about 2 years. And so if it happens to provide habitat, that's a hugely added benefit.
Okay? Yes?
So if we think that a larger scale
Yes.
in a city, for example, how to reach this environmental benefits if it's in this scale? And what about the existing cities? We are thinking about building new buildings like this, but what if it's an existing city and it's not environmental good?
Right.
So how to improve the city to become something that we can call it's an environmental friend?
That's a great question. So I think that some of these projects are in existing cities. They may be all new buildings, but the kind of prosthetic device logic could apply just about anywhere. Carl Steinitz is a brilliant professor of landscape architecture at Harvard University, and he says that if you don't get things done well at the planning scale, it doesn't really matter what you do at the building scale. It's all going to be wrong, which is fine, but I'm an architect who works at the site scale, and I don't have the opportunity to affect things at the larger scale. So I'm trying to think about it as more surgical scale interventions in the city. And there are some examples. There's a South Korean architect who's looking at these sorts of interventions for 70-story buildings in Seoul. So I do think there's examples of that, and I would agree that we have to deal with the infrastructure in the urban environment that we have to work with. So what can we do about it? Are there pockets of space, whether above ground, way above ground, or on the ground, that we could start to reappropriate to do these things? There's this movement in San Francisco right now where in the middle of the night people take jackhammers and remove the parking spots and plant gardens. There's a whole movement right now, which I kind of like a lot, because the amount of area that automobiles take up is just unbelievable. And I know we have an incredible parking automobile problem in this city, but if there's any way that through kind of acupuncture we can appropriate urban outdoor space, we can do a lot of good work.
And along these lines mentioned in San Francisco, an idea of just cutting trees with a lever was a very famous thing that happened. They wanted to retrofit and upgrade the stadium at the University of California in Berkeley. And in doing so, there was an area which had a few trees just in front of the stadium. There were activists that decided to live in the tree. And this went on for months and months. And the whole city was up against trying to demolish these trees so that the project would go on. So the idea of plantation, the idea of ecology of the city is becoming more and more, really more and more important. When you actually look at the Google map now of Cairo and a lot of other cities, there are vast areas without a tree. Vast areas without a tree. This is becoming really a major problem. So I think it's very important to think about this idea of ecology in the city and ecology in the urban center. I think this is very important of how the architecture will play a role into this whole. Let's go back to the question.
So if I may really quickly add, the cities of Oregon, if you could really call them cities, they're all built on rivers. Cairo. I mean, the majority of the world's cities were built in places of incredibly high biological productivity. You know, we're attracted to these locations for the very reason that fish and birds are attracted to these locations, right? So the potential is there to do things that have, in these environments, that have dramatic impacts, really dramatic. And you can you're not going to recreate nature in Cairo, but you could start to think about processes, ecological processes, that you could start to reintroduce. And actually, I think it starts and ends with water.
What is a major area that has a fantastic ecological system that's related to birds, actually? So do you know of a place? It's in front of the zoo, this street, Brook Street. There is actually these tall trees that are there, and they are a main habitat for kind of birds moving back and forth into it. And at a point of time, birds come in, and they will have all types of hooks on cars and stuff like that. This is a fantastic kind of example that at a point of time, I'm sure, some investor will come in, just tear these down, and it's not forever. So can we recreate some of these aspects into the city again, and they become habitats that will create different type of livability and action and so on? I think this is very intriguing. How can architecture play a role to that? Yep.
I want to ask a question, a subjective question regarding the new cities of Cairo, such as the new capital, the new Cairo. I just want to know how ecological parameters changes for such cities, and I want to know if there are like previous examples that you know or previous experiences.
How can we think about kind of a new role, a new logic for the new city that is planned to be built in Cairo, and how could that be worked out?
Well, follow the water. But, I would I mentioned Mark Wilson, the ecologist in Portland, who follows construction equipment and does perk tests of the soil, and he's created wetlands. And so to me, thinking about construction processes if we were intentional and if we were partnering with ecologists and biologists, could those very processes help to anticipate productive ecologies when the project is mature? Could foundations of buildings divert and collect water in intentional ways? Could all of the surface, if I have to create a facade, maybe there's some possibility for that facade to double in use. If I have to create a roof, maybe there's a possibility for that roof to do the same thing. There's an experiment in a cold climate that I know of where they're actually a smaller building, they have beehives along one facade. I think it's in Minneapolis, really cold climate. And they have to keep the queen bee warm. So they're actually using the bee wall as insulation to keep the spaces warm within in this really, really cold climate. And I don't know if it's going to work, but it's worth experimenting with these kinds of things to see what will. So it's not necessarily adding a number of things, but if I need insulation, I might start to think of a different way of realizing it that also supports these other functions as well.
Okay, yes?
I'm an anthropologist, so I'm actually wondering about the role of the residents or users in these structures in terms of maintaining these environmentally sound features, and whether or not that is a consideration when you want to bring these kinds of ideas to contexts like Cairo. And I'm not talking about the cross-cultural encounter, I'm talking about just the practicality of asking, for example, residents in low-income neighborhoods to engage in these kinds of practices. And again, not a cultural context issue, but a financial, time, whatever.
It's a really good question. Unfortunately, a lot of green buildings in the United States are built, and I hope I can answer your question. It's a very good question. These really expensive, technology-driven green projects are built in the United States. And so when you buy a toaster, you get an instruction manual, and when you buy a $100 million building, you get the keys, and nobody actually tells you how to use it. And so we have all of these buildings that are built in the United States that aren't performing even remotely close to how they were designed to be, because it requires specialists with with skills who can manage those buildings. So we're starting to develop 2-year master's programs of building systems management, blah, blah, blah. Our approach at Oregon would be just to simplify the system as much as you possibly can. So that's one thing. So the more rudimentary, the better. My wife's a landscape architect. She does a lot of drought-tolerant landscape design. And so you might have, her whole approach is you might have to maintain it for a short period of time, but by the time it matures, it basically can take care of itself. So as little maintenance as possible. But I'm not trying to discount those kinds of realities. And then there's some really thoughtful experiments in sustainable architecture that were low tech and low cost, but they did not work because there wasn't the cultural acceptance of what was necessary to ensure that it would. And so I think it's a very important question about how we could introduce these, and could the argument that cleaner water and cleaner air very inexpensively, would that be an argument that would be palatable to people? So there's a book called The Blueprint Sustainable Farm by a guy at the University of Texas. It's called Technology in Place, The Blueprint Sustainable Farm, by Stephen Moore at the University of Texas. And they built this wonderful project in Laredo, Texas on the Mexican border for sustainable agriculture. It's going to provide jobs and do all this, and it failed completely because the kind of social, cultural realities were not sufficiently addressed.
Yes?
Can you probably give examples of good interventions of urban transformations where the local communities were engaged from the very beginning and they were part of the co-creation and the co-implementation?
Yeah, so at a smaller scale, there's a number of nonprofits in the city of Portland, Oregon, and I'm trying to think of it should be, I email them all the time, but there's a guy named Mark Lakeman who's doing these city betterment projects, which are first and foremost projects in civic engagement. At a much larger scale, I think this is a really interesting project. There was this Peter Calthorpe, is an architect in San Francisco, and he was hired to do this Envision Utah project. So the state of Utah, very dry, Salt Lake City is growing like crazy, and they were having air pollution problems and all this stuff, and so they did this very large public participation process. And it's very important, it's a very conservative place politically, and so the idea of green, this and that is not going to appeal. But they basically sent out the survey to, I think, 100,000 people and said, what do you rank what you value the most? And do you want big automobiles? Do you want highways? The thing that people want, 1, 2, 3, is education for their kids, clean air, and clean water. And all the other things are more important, but those are the top 3. And then they said, okay, this is what you value the most. Here are these different development scenarios for this metropolitan area. If you do continued low-density sprawl you're going to have more traffic, you're going to have worse water quality, poor air quality. If you look at more dense, compact development. And so I think if you could create that leveling effect by asking people what they truly value, you're able to achieve some really interesting things. The last one I would say is Fritz Haag, who's an architect turned artist. Look at the website Edible Landscapes. Edible Estates. So he does these urban gardens, and what he does is he gets the kids involved. The parents are all like, what are they doing? What are they doing? They're transforming, and then he just gets all the kids excited about it, and he uses the children as the means to convert others to the possibilities.
Yes?
Actually, it's a comment, not a question.
Can you raise your voice?
It's a comment, not a question, but I like the idea of when you talk about the water production and the water cycle in the building, you just think directly that what the importance of the water element is the building. So when you talk about water, directly you talk about the livable things.
Yeah.
Every living creature is made of water. So when you talk about water as a building, actually turning it a livable thing. The livable creature is the environment.
Yep.
By adding more biological injections, like the mushroom filtration is what you mentioned,
Yeah.
becoming more like a real livable creature.
Right.
It's like you said about the machine is a watershed.
Yeah.
Really. So I think actually applying the water in the building, think about it more, to make it like a living creature.
Yep.
So I like this.
Great. Okay, I have a question. How can we do that education-wise? We have a lot of interesting ideas about kind of integrating aspects, integrating systems, bringing others into the table of architecture.
That's critical.
How can we work that out? How did it succeed in how can we start and appreciate some creative thoughts from home?
So my theory is learn enough to be dangerous. Okay. So I'm not an ecologist, but I learned enough from this ecologist to recognize that it might be valuable if he was not brought in as a consultant after the basic architectural organization had been decided upon, but bring him in at the beginning. The guy who's going to use sweat to grow green gardens, he's all frustrated because he's always brought in toward the end of the process, and he thinks he could be a lot more effective. And the architecture could get a lot more interesting if he's brought in earlier on. So think about, so what we do when we teach a studio, I bring my ecologist colleague and we actually write the problem statement together. And so he has all of these performance specifications relative to his world, and I have mine relative to my world, and we try to think about how it doesn't have to be two separate things, but it has to be combined. Sustainable architects tend to think about the building envelope and everything within, and sustainability-minded landscape architects deal with all the surrounding space. So what could start to happen if you really started to think about these as synchronized systems? And again, I think water becomes the connective tissue between buildscapes and landscapes.
I think it's really, it would be only a comment. Because actually we are in a very different situation.
Very different. Yep.
And we are very thankful for you actually and for your insights and whatever the whole idea is actually that you are presenting to us. I think fundamentally what we need to think of is how architecture reconcile with the environment.
Yep.
And this is really very important, and then how to develop arguments or be convinced actually of arguments of how is keeping or concerning and thinking of the environment is really crucial for our survival.
Absolutely.
It's really,
yeah.
It's not really a question of how much that we will be saving actually out of
be concerned with sustainable. I think it's a matter of survival. We are now in a certain level of challenge that is, this question really, so it's a...
So you're in a completely different environment than Eugene, Oregon, but on the other hand, you have the Nile River and you've created a bunch of rock outcrops which provide shade and happen to have water systems in them, okay? So let's like unscrew this and move it over here and put it over here, and let's get 27 more uses out of it and see what we might be able to accomplish. That's what I would say. You've actually built something so it actually functions more like Oregon than it does like the desert in a way. So maybe there's something we can do.
Okay, again, at the end, we'd like to really thank Professor Brook for his interesting input and his lecture. And actually, if you don't mind, I hope that if there are some serious kind of issues to communicate with Professor Brook at the point of time, issues that are related to some of your research, according to in your kind of studies and so on, please feel free to communicate with me or Dr. Nabil so that we don't bombard him, but communicate with me and Dr. Nabil, and then we will be able to convey this to him. And of course, I think he could communicate with you so that there could be some continuation and some benefit out of what we're doing in general. I thank you all for coming, and I hope this was some input and some addition to knowledge and to some curious minds. Thank you.